Hello everyone. Today, as the title said, we'll be making a simple godot app that can work on your phone. There's a project I've done before. It was one of the first projects I did when I first started Godot, and I think it's very helpful to learn some of the concepts and how some of the nodes work. So let's get to it. The first thing we're going to need to do is think about what we're creating. So I always like to visualize it. We will be needing to create a grid, of course, and each grid needs to be, since it's a Sudoku board, it needs to have 9 tiles this way and 9 tiles that way for a total of 81 tiles. And the best way to get 81 tiles in a grid would be to first create the tile. Rather than creating it all together, we're going to create a separate tile component and then add it to a grid later on. So let's start with that. First thing we're going to need is change this to, I like to start with a panel container first. Then we're going to add a button to create our first cell. Change this to whenever we're working with control nodes, I like to bring it up into the center. And this is gonna be our working cell. After that, I like to make a minimum size. Since we are making this with the consideration that it's going to be going on mobile, we want to make sure it's not too big, so it doesn't take up too much of the screen by itself, but it can be too small so that people are able to press on it whenever they want to. I think 55 by 55 should work fine for mobile. The button doesn't need its own size. It'll just inherit from the parent. Then we're going to save it. Let's create the scenes folder so we can start organizing from the beginning. We're gonna have stage for things that belong to the stage, and UI for things that are gonna belong to the UI. Further organization. We're going to save our cell to the states folder. Then we're going to create our grid. We have a grid container, of course. We'll be using that. Bring it to the center. So this is going to be our Sudoku board. We know we need 9 columns. So we'll make it 9. Rather than grid container, we'll call this cell container. This will allow us to work with it better. Okay, so how do we fill up this cell container? We're going to create a script for it. We don't have any scripts yet. Whether this is checked on or not doesn't really matter. Mine is already checked off, but if you just checked on, that's fine too. So now we'll create our grid container script, and we're pretty much going to say that in the ready function, we're gonna need to get a reference to our cell first, actually. So let's do that. And we do that by typing in @export variable, and we're going to do, let's call it cell scene, which is a pack scene type. So what @export does, if you don't know, is it gives us the ability to export the variable to the inspector here, so we can just work with it. And what we'll do is we'll drag our cell scene into our cell scene variable. That way they're always connected, even if this switches location for some reason, or you change its name later on. Well, if you change your name, I think you have to redrag it, but if you change its location, it does stay pointing to it, which helps during exporting. So we'll go ahead and do that. Now that we have a reference to our cell scene, we can say we create a variable, call it tally, an integer, of course, start at 0, and we say while tally is less than 81, we want to create a cell, which is, in this case right now, it is a control node, so let's leave it as our general control, and it's going to be equal to cell scene that instantiate. So in case you're not familiar, a cell scene, that's a packed scene. This means a scene. In order to use it, we have to instantiate it. Just use that cell scene that instantiate. This will give us a cell scene, and then to add the cell scene to our grid container, we just say add child. We'll add the cell. So this should give us a grid with 81 cells. We start the scene, and let's see what we get here. Okay, so nothing happened. And if you're not new to programmer, you know why. Because we didn't increment tally, so it just stayed in an infinite loop. So tally plus equal 1. And okay, there we go. So now we have 81 tiles in our grid, and they're all clickable. Okay, so we got our tiles, we got our grid. What do we need to work on next? Well, let's start by putting in the ability to input info into the button. So let's go back into our cell scene. Let's give it a script now. And let's go here. Create a ready function if you don't have it. Give it some variables. The first variable is a value. Since it's going to be a Sudoku board, we're going to need to show a value to the user whenever they try to change its value. Because in a grid, it's good to have information like the column. Don't forget to do your typing, of course. This will help in the future. It's good to get the habit of it always. Another thing you might not realize we need is group. So every cell needs a value, a column, a row, and a group. How do we get those values? Well, we go back here, and before we add the child, before we add the cell scene to the grid, we can give it all its values. It's important that adding the child is the last thing we do, and you'll see why in a few minutes later on. But for now, we'll say cell.row. Column, start with column. Is equal to the tally value module the number of columns in the grid container. So columns, even though we didn't make it a variable, is a property that exists already in the grid container. So you just have to say columns, and godot knows what you're talking about. And that's going to give us what column the cell belongs to. And to get the row, we do cell equals tally divided by column. divide it into 9 groups. We're going to say that if its column number is in 0, well in this case we'll do 1 to 3, and its row number is in between 1 to 3, then you're in group 1. If the row number is between 4 and 6, then you're in group 2, 3, 4, 5, and so on. So the way we would code that is we're going to say, I'm probably going to fast forward this part, but it's going to be okay, so we got that done. I had to change something at the very beginning. I said it would be cell 1, 2, and 3, but it's actually at the beginning. If its row is less than 3, it's 1. If it's between 3 and 6, then it's group 4 because we're going down. And then if it's the other one, then it's group 7 if it's higher than 6. And then you can do that for all of them. You can look at the code right there. So once we do that, every cell should now have a column, row, and a group. So now what we need to work on next, and we clicked on our container scene here, we can see that there's no information showing yet because we didn't assign any. So let's start assigning some information. For this part, we're going to say that the value that the button shows actually, so we're going to go ahead and give it a unique name to the button, and we're going to go ahead and add it to our scene on ready, and that allows us to call it like this: button dot text should always be equal to whatever the value is. And we can actually say here that we want every cell to start with a value of 0. Let's see. Makes use of. Do that fix it here. Okay. I forgot. We need to do the string of value. Since value is an integer, we need to make sure we turn it into a string before we give it to the button text. Okay, so we go here and launch the scene again. Okay, every button now has a value of 0. Okay, so now that, since we have the groups, we can also start making it easier to look at, since this is going to be a little bit annoying. So let's create some colors. We're going to say, let's see, I want a blue color, so let's create rather than like a variable, let's create a constant, because this value will never be changing. Let's call it main blue color. It's going to be a type color. And if you're not familiar with how colors work, you simply type in the keyword color and you choose a value for red, green, and blue. If you're not sure how your RGB values work, you can come over here to visibility. And if you go to either modulate or self-modulate, you can play around and see what your numbers are. So for example, here, if you switch it to raw, you can see what percentages you need to get the color you want. So since I want a blue color, let's see, a little bit lighter. Okay. So right here, we need a 33, 45, and a 78. So we do 0.33, 0.75, and 45 and a 78. 45.78. And you need a comma here. this will create our main blue color. You can go ahead and reset this so it doesn't affect your scene later on. We're also going to create a second color. Let's call this main green color. It's going to be a color type, of course. Go ahead and call color, and then let's go see what kind of green we want. We go here. Maybe a little bit darker. Okay, that was good. So that's a 14, 45, and a 30. Let's see if I can remember this time. So it's a 14, 45, and a 30. That'll give us our main green color. And then we want a variable color. That's going to be a color type that we're going to use to make sure we know what color our layout is. We're going to say that if the group number of the cell we're working with is in these ranges, let's go with 1, 3, 5, 7, and 9. 1, 3, 5, 7, 9, yep. Then we want the color to equal blue. And because we did typing above, we actually get a little hint here that shows us what color we're working with. So we got a main blue color. Else, the color will be equal to green. Then in the process function, we say that we should always be modulating. Well, actually, we don't need to do, since it's going to be an unchangeable color, we don't actually need this. So we're going to say self modulate should always equal whatever the color value is. So let's go back to our cell container scene. We're going to start it, and everything looks green. So why is that? If we go over here, we're saying that if the group number is in 1, 3, 2, it should be blue, but everything looks green right now. Let's debug that a little. Make sure group numbers are correct. Make sure I forgot to do the thing I told you to do, which is reset this. So let's see if that helps. Okay, it did help a little bit, but everything's white now. So let's go back to, and the best way to debug a grid is to get its button. I'm gonna go ahead and press, if the button is pressed, just give us some information. So print, we're gonna say the group. So let's go over here, and this should be in group 1. It is. And this should be in group 9. It is. This should be group 7. Okay. So we know our grouping is working. So what could be wrong here? So if you go to the 2D scene view, you're gonna see that if you go to the inspector, visibility, and self-modulate, and change the color, you actually notice that no matter what we change the color to, we actually don't see the color change. And that's because this panel doesn't really take color. If you zoom in, you can see that it does somewhat change color, but it's not very visible. And the way to fix that is we go to theme overrides, styles, we're gonna click this, we're gonna create a new empty style box that's flat. And that will actually allow us, you can leave it black if you need to do anything else after that. That will actually allow us to now change its color visibly. So reset it so it's not in the way. And now, if we did that correctly, we should be able to get our grid. So there we go. Our groups are correctly matching, and now we have a little bit more visual distinction, so we know which group is which. So this is 0 to 3, 5 to 6, 7 to 9. Okay, so we got it looking well. We got our values there, but what what should we start doing next? We can now actually start going straight into generating a valid Sudoku board. So the best way to do that is we're going to need 3 functions. We're going to need a isValid function, which is going to take in a cell, and it's going to take in a number, and it's going to return a bool. For now, let's return false, so that gives an error. Make sure you're spelling correctly also. So the reason we're going to need a bool return here is because we're going to be needing it for our generate valid grid function. This returns a bool also. That makes sense later on. And we're going to need a remover function, which takes in a number and it returns void. You want to get in the habit of making sure you express what your function should be returning. It makes it easier for processing later on also, and just in case you make a mistake later on. Okay, so we have our 3 functions. And one thing we're going to do before we start those is actually create a class name for 2 scenes. Class names are helpful for a couple of different things. I'm going to go ahead and call this cell. And we're going to call this let's call this grid for now. Okay, and we go here. Switch this into a type of cell. And what switching the class name does is allow us to get more information when we need it. So there's a type of cell. We're making sure that godot knows exactly what we're working with. And let's work on the first function. So the isValid function is going to need 3 variables. It's the column save, gonna be a bool, and we're going to start it off as true. It's the row save, start it off as a bool, that's going to be true, and it's the group save. We're going to say is that if at the end of this column is safe and row is safe and group is safe, then we're going to return group. Else, if it passes all that, then we're of course going to return false. Okay, so since we have our function set to true already, how do we check if they're false? Well, we're going to need up here, whenever we're adding our cells, we're actually going to need a variable here. Let's call it all cells, which is going to be an array of type cell. Let's initialize it. Say that every time we add a child to the scene, we're also going to add this cell. So now we have a list of all the cells we have in the grid. You could also do, of course, get children, but I think this works a little bit better. And now we're going to do for cell 2, since we already have a cell variable here, in all cells, if cell 2 that's not equal cell, making sure we're not checking the same cell we're supposed to be checking. What we're going to be doing is comparing if any other cell in this same column, row, and group have this number we're trying to put into this cell. So if the cell does not equal the original cell, then we're going to have to check that if this cell's if the cell 2 column is equal to the cell column, then we check to see if the cell 2 dot value is equal to the number value we're trying to check. So this function, which I think I forgot to mention, is going to take a cell and a number and see if this number is a valid number for this cell. So if a cell in the same group, column, or row that this cell is already in has that number already, then we know that it's going to be false. So I'm going to say that if the cell in the same column has the same value, then column safe is going to be equal to false, and we don't need to be in this loop anymore. So we're going to break, because as soon as we find one false value, that's enough of a reason to break. Then we're going to say if cell 2 dot row is equal to cell dot row. And then we do the same thing here. So I got the if here. If cell dot row equals go to the value. Then do the same thing. Let's say row length equals then the same thing for the group. If cell 2 the group is equal to cell dot group. If cell 2 dot value is equal to the number, then safe is false. And we break. Okay, so make sure you double check this, because this function will be doing a lot of work for you. You gotta make sure that you're not checking the same cells. You have to make sure that you're telling it that if the cell 2, if you're checking the value of cell 2, it equals the number, you gotta make sure you break, you gotta make sure you set it to false. Otherwise, you could be getting some wacky boards. Okay, so that is our isValid function. Then we're gonna generate our grid. And to generate a grid, we're actually going to do a very simple process. Let's create a empty cell folder, which is going to be another array that's going to contain cells. Make sure it's capital. We initialize it, and we're going to say that for every cell in all our cells, if a cell dot value is equal to 0, we want to append it to our empty cell holder. We're actually getting an error. Let's leave it here. Not sure why I deleted it. Okay. And this is going to be a recursive function. So we're going to have our first check right here, that if there are no empty cells, so if empty holder dot cells have a valid value, and we're going to return true. What's this thing say? I forgot to put an if here. If empty cell holder that size equals 0, then we return true. Okay. And the reason we're going to do that is because we're not going to create a cell that's going to be a type cell, which is going to equal our empty cell holder indexed to 0. So we just take a random cell. We can actually shuffle it here. So let's shuffle this. That way we're working with random cells. We're going to take the first cell of the empty holder, and we're just going to perform a valid check on it. Well, actually, we actually don't want the random. We're going to do it by order, actually, just for debugging's sake. Now, what will we be checking the cell with, of course, is some numbers. There's going to be an array. We're going to say that it's a range 1. So, if you think about Godot, range is going to create a list of numbers between 1 and 9. So it's an exclusive list. So our last number will not be in the list. So we do it 1 through 10. So we get the numbers 1 through 9 in the list. This we can shuffle along. We shuffle a number. And now we're going to simply do the same. That for every number in this list, we want to do an is valid check. So if is valid, the cell we got from our empty cell and whatever number we're checking now, if this returns true, then we want to change the cell's value. So one of the good reasons to create a class is so that you get the typing here, so that our cell class is going to grow bigger. We're going to have a lot more variables, and you want to make sure that you always know what you're working with. So when you make a class, you get access to all its values. So now we can actually see here all the things we can change, and one of them is its value. So we're going to make this whatever the number is. And if we think about the game Sudoku, we know that we actually need two values. We need a value that the user can see and change, and then we need a value for what its true value should be. So this value should be never changing once you set it the first time. I'm not sure we're going to need to do that. It's going to be an integer, of course, but we go here and we say that cell that true value is also equal to this number, and then we recursively call generate valid grid. So we're going to say that if generate valid grid returns true, then we're going to return true. But if this returns false, we don't need an else statement here because we have a return statement here. We're going to say that the cell, that value, should go back to being 0. Okay. So what that's going to do, if we go back here, is that's going to check all the 81 cells, and if it gives it a number here that doesn't match, it's going to go back here and try a different number. And if it tries all the numbers, it'll return false, so then it will return again and try a different number here, and keep doing that until it returns back to whatever number works next. So that's why we changed its value back to 0. If you don't do this, you're going to get an incomplete board, and I'll show an example of that later on, but for now this should work. Okay, so now we have, so if we go here, Make sure you're outside the while loop. So the tally is the last thing we did in the while loop. So make sure you're outside of that. And we call generate grid. This should give us a valid Sudoku board. Okay. So to check if it's valid, let's do a little simple check. So 9. Do you see any other 9s in this row? Do you see any other 9s in this column? Do you see any other 9s in the group? Let's see here, 6. Do you see any other 6 in this column? Do you see any 6 in this row? Do you see any 6 in this row? Okay. So we do have a valid board. And now let me show you what happens if we remove the 0. So if you forget to do this part, if you go here, you're gonna get this. So what happened here is that it made all the way here, then it got a value error somewhere in this part, and it came all the way back. But since we never changed the value, it just messes up the whole grid creation. So you gotta make sure that you leave here cell.value is 0 if this returns false. Okay. So we have a valid grid. Now all we need to do is make it playable. So the reason we created a valid grid first is because, in my view, that's the best way to make sure we actually create a unique grid. Of course, if you have different ways of getting a valid grid, you're welcome to do it. This is just the way I did it. So the next thing we need to work on is removing the numbers. So let's go ahead here and create a variable. Let's call it difficulty. Let's give it an integer. Let's start it off as 1. And we're gonna create another function here. Difficulty adjuster. It is a void function. And all we're gonna say is that if difficulty is 1, then what we're going to do is call the remover with, let's say, 20 numbers to remove. Else, we're going to remove 40 numbers. Else, we remove 60 numbers. The more numbers you remove, of course, the harder the Sudoku puzzle becomes. And now you have to think about what is the best way to remove these numbers. If we just did a straight remove the numbers in a row, so just go ahead and remove, the first 60 numbers that it encounters, that would probably be a weird one, and it probably wouldn't generate a very fun board. So what we actually want to do is go ahead here. We're going to create an all cells copy. In godot we use duplicate. Like I said, it's true to make sure it's a deep copy. And the reason we're copying this is because whenever you do a copy of a list, if you don't do duplicate, you're going to get the same list in this variable, meaning any changes you make to this list will also apply to this list, and we want to make sure we don't do that. So make sure you always duplicate. You don't always need to set this to true, but I like to do it just to be safe. And we're going to say that while actually we're going to create a variable first. We're going to create another tally integer set to 0. We're going to say that while tally is less than the number, so whatever number the is, in this case it's going to be 20, but while tally is less than the number, we're going to go ahead and create a cell, type cell, which is going to be equal to all cells copy. Actually, let's do all cells copy. Let's shuffle first. We want to make sure we're moving random numbers. All cells copy. Dot pop. We can do front here. So the reason we're doing a pop here instead of doing an index for removing is to make sure that we're removing these from the copy as it goes along, and we have less cells to work on, and that way we don't accidentally remove the same value more than once. So we got our cells copied, we shuffle it. Then the cell we're going to use is whatever cell is at the front. So we're going to pop front. This removes the cell from the list. So we're going to keep shuffling the list every time we come around. And then we just remove the number from it. Okay. And we're going to say that this cell is going to have its value changed. So the value of the cell will equal 0. And we actually need to give our cell class some new variables. We're going to give it a guessable variable. It's going to be a bool. We can set this to false right away. And guess correctly variable. It's going to be a bool. We're going to set to false right away. Okay. So we go here. We're going to say that this cell is now. This cell, sometimes this happens. Well, I think I broke here first. So we have a guessable variable that's going to be true, and that's gonna help us differentiate what our values are, and so we don't get stuck in a while loop. We do tally plus equals 1. Okay, so that should be removing 20 random numbers. Oh, we didn't call it. So we go here, we generate a valid grid. We're gonna call, we don't call the remover itself, we call the difficulty adjuster. So it will remove the right values for us based on whatever the cell container holds. So, okay, so 0, 0, okay. So now, let's start working on some visualizations because this is pretty terrible. So that's the reason we have our guessable, so we can differentiate between cells that are guessable and not. And we're gonna come here and we're gonna say that, let's create another color. Let's call this orange. It's gonna be a type color. So we got 78, 23, and 15. 78, 23, and 15. So that's gonna be our orange color. And now we're gonna need another variable called button color. And that's gonna be a type color. And the reason we want a variable for the button color is because if we change the color of the panel container, we get a very wacky look. So let me show you that real quick. So we're gonna say if guessable, then we're gonna say, let's change the panel container first. Self-modulate equals orange. So that's gonna look like this. That destroys the look of our grid, and it looks kind of bad. So that's why I personally like to just change, like to say button color is equal to orange, and then the ready function we just say that the color, our button here, remember we have it as button should self-modulate to whatever the button color is, and that's gonna change how it looks a little bit better. actually, because we gave it a regular color, we actually need to go here in the cell section and create another color. So because we're giving it the color of the button color, we need to make sure the button color has its own default color. So we're gonna go in, type in white, make a color. It is equal to color. And for white, we just do 1, 1, 1. And we're gonna say here that if you're not guessable, well, we actually just go here and say the default color of a button color should be white. And now we go back to our cell container, start the scene. We get this. Okay. Guessing I forgot to do this. We don't actually need this here, which I just say right here that the button should always self-modulate to the color of the button. And we can take this off. Now, that should give us the look we're going for. But that ruined that, so now we're gonna go back here. We still need this line. Okay, so that's a little bit better since the orange isn't in the way now. It's only the button and not the panel itself that's changing color. We can fix this later on too to make it a little bit better looking, but for now that's fine. So now we know where our guessable values are. You can count them if you want to make sure we have 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So you know our remover's working correctly. Okay. So we now have a valid board. We now have a way of removing numbers from the board to make it a game. So now we need to work on inputting values. So we're gonna go back to our press button here. And we need to think about this. Okay, so one of the ways we could input value is by creating a line edit every time we click, a user clicks on a button. And that's going to give them the power to enter it. But since we're going to be making this with a mobile friendly target, we need to keep in mind that when we do a line edit, that's going to pull up their keyboard pretty much. And that's going to be annoying if what you're trying to do is just type in 1 through 9. So I think the best solution is to create our own number pad. And so number pad is going to be a very simple number pad. We only need the numbers 1 through 9, and that's going to be something like this. So we're going to have a button, of course. We're going to need, you could do either horizontal first or vertical first, doesn't really matter. I'm going to do horizontal container with 3 vertical containers. Actually 4, because we're going to need an extra button here to close that out. So we're going to need 4 vertical containers. And that's going to be our number pad. And then when you think about it, you can either add in 9 of the regular buttons into this number pad. But what that's going to require is going to require you to create 9 buttons that each have their own signal to then submit whatever the value is. So this is 1, 2, 3. You're gonna have to go to this button and say, if this button is pressed, submit to 1. If this button is pressed, submit 2. If this button is pressed, submit 3. And you're gonna need to do that 9 times. Now, I think a better way is to do what we did earlier. So just like we created a cell and then we created a sub-container, the best way is to create a number. So let's get a button. And we're gonna call this num button. Let's do it this way. And that way, we only have one button that we need to create a signal for. That is then the main button in our number pad. So we're gonna go here. Always move it to the center just for looks. Save it. This is gonna be part of our UI. Then we're going to create another scene. There's gonna be a regular control node, and I'll explain why later. But we're gonna need a regular control node. Make sure it's a control node. And we're gonna go here, make it center. I'm gonna go ahead. Like I said, you can do either H box or a B box. These will arrange its child in a very specific manner. So we're gonna do H box, and then a V box. We're gonna need 4 of these, and each V box is going to have one of these special buttons we're going to be making. So let's create a script for these, and we're going to call it number button. Save it. Over here, let's call this number pad. And we're going to be creating script for it. Last name number pad. Okay. And it saved it in the UI. Now, because we didn't save it before, the number pad script is going to go outside its folder. So I just want to make sure you bring it back into this folder so they're together. Okay. Okay, sorry about that. So now we have our number, we have our number pad. What we're going to do is we're going to give this a child of the number we just created. So I'll just duplicate here. Each V box is going to need 3 buttons. And the last container is going to have a regular button. Okay. And so now, the reason we did that is so that instead, if you use the regular button for all these, you have to go here into the signal property, the press property for each one, just to say submit the 1, submit the 2, submit the 3. So rather than that, we're just gonna have this special button we created, and we're gonna handle all the logic right in this button. So the first thing, let's give these each a value. So I'm gonna say you can go 1. You can decide which way they go. I usually go this way. 7, 2, 8, 3, 6, and this button's gonna have an X. That's gonna be our close button. Okay. And I'm gonna go here. We're gonna create a signal that when this button is pressed, it'll do something. Okay. So let's work on the logic for this. Okay. So we're gonna need to go to our subcontainer, and we're gonna need a way to input information. So we're gonna say function input answer. So input answer will take, just like our valid check, will take a cell of type cell, and we'll take a number that's going to be an integer. It's going to be a void function, and it's going to very simply say that if the cell's true value is equal to the number, then we change everything about that cell. So we're going to say cell value is equal to the number. We're going to say that the cell is no longer guessable. We're going to set it to false, but we're going to set the guess correctly variable to be true. That's going to be helpful later on. So that means we got the answer right. Now, if you want, you can also create a variable here called mistakes. It's going to be an integer. Let's make it 5. Else, if this wasn't the case, then we're going to say mistakes minus equal 1. And then we say that if mistakes is less than or equal to 0, then we're gonna create a game over scene and add it to the tree later. Okay. So we have our input answer in the grid. So how do we input from the cell? So every time a button is pressed, we want the user, and it's a guessable cell, we want the user to be able to input their answer. So we're going to say if this cell has a guessable value of true, then we're going to be able to call the number pad so they can input their answer, and then that's going to take from there. So how do we give the user the control of creating the number pad from the cell? One way to do that is to go here, and we're gonna put pads here for now. We're gonna go to the cell here. We're going to do what we did before, where we're gonna give it access to a different scene. We're gonna say export variable number pad theme, which is going to be a pack theme. So we go to the inspector, and we now have our number pad scene. We're gonna go here, drag it in. Okay, so now our cell has access to a number pad scene. And actually, we forgot to do one more thing. So if you're not familiar, Godot has the options to use groups. Groups are a way to identify nodes without being in the nodes themselves. So we're going to go here, and we're going to assign this the group of number pad. Make sure you get the spelling correctly here. This is a very big deal. If you get the spelling here, you're going to probably get a spelling wrong. You try to call it. And we're going to go here, and we're going to say that the variable number pad, which is going to be a type number pad, it's always good to add typings to these variables to make sure you get exactly what you want. It's equal to, we're going to call the get tree, which is going to call the entire scene tree, and we're going to do the get first node in group function. Now, if you're using an older version of Godot, this might be called, I believe it was get first node or null function, but I'm using 4.3 and they changed it to get first node in group function. And we're going to type in number pad, and we're going to say that if we're going to add the child number pad, and that should be all. So now, so that should be it. So every time you press a button, we're going to get the number pad. And, okay, I'm getting ahead of myself. We actually want to do the opposite. So let's do number pad scene getting ahead of myself there. We actually want to do it this way first. I can show you why we want to do why we want to do it the other way. So when we do it this way, let's go here, start a scene. When we click on a guessable cell, we're gonna get our number pad. But if we click on another cell, the number pad stays. Now, I'm sure you see more than one problem right now, but we'll fix them as one by one. So every time you click on another cell, you're gonna get another number pad. So in order to avoid that, is why we want to do it this way, where we're gonna call the getTree function, and we're gonna say if you find a number pad. So if number pad does not equal null, meaning you found one, then I want you to get the number pad parent. So whatever null that number pad is attached to, I want you to get it. And I want you to remove the child number pad. So remove the number pad. And then I want you to call number pad that Q free. And it is going to find the number pad that exists already, and then remove it from the parent. And then it's going to call Q free on it, which is going to remove it from the scene entirely. I was told this is the best way whenever you're removing a node during gameplay. The safest thing to do is to remove it from the parent first. That way you get less chance of error. So once we do that, then we say number pad. So number pad is now equal to a number pad scene instantiate. So just to go over that again, if we get a number pad, we run this code where we find it, remove it from the parent, and free it. But if we don't find a number pad, then this is going to be null, and we need to give it a value. So the value we give it is always a new scene that instantiate. Then we add the child, and so now the behavior should have changed. Let's see. Oh, I use removed instead of remove child. So you're gonna make sure you know what functions you're always calling so you don't get those errors. Okay, so now, okay, there we go. Now it's working. So every time you click on a guessable cell, you're going to get a new number pad. Okay, now let's work on making sure the number pad actually works. Now, if you go here, you saw another problem was that the number pad starts to get clipped, and that's because as we're adding it to a child of this cell here, the other cells are drawn above it, so it's always going to clip our stuff. So in order to avoid that, we go over here to our number pad, make sure you have this number pad clicked so that you're making sure that the node you're changing. If you do this, you're going to change this node. So make sure your number pad is chosen. You're going to go here into process. You're going to change its mode into, let's see, sorry, not process, visibility. You're going to go to top level. So that should fix that problem. But it creates a new one. Now it is drawn on top, but it is no longer being drawn where we're clicking. So how do we fix that? So we're going to go to our number pad. We're going to create a ready function if you don't already have one. And we're going to say that the position of the number pad should be equal to its get parent and its global position. You can actually do position here. You need to do global, but I like to do global just to be safe. So that should fix that error. Okay, so now our number pad is drawn above, and it is also drawn right above where we want it to be. Okay, so let's fix the second problem. This is going to be way too small for mobile. So we can actually go back to our number button, and we can go here, and we're going to give it a minimum size. So we're going to go, the minimum size, it should be, let's say, we want it to be pretty clickable. Remember, people are going to be using fingers for this, so we want to make sure that they are able to click it correctly. So we want it to be at 65, let's say. So let's look at that. Okay, it's a little bit better. And then let's go to the number pad, and you can increase the separation between the numbers, and that's going to make it even easier for the user. So we're going to go here into the HBox container. We're going to go to themes overrides. I'm going to do constant separation. I like to do 20 for the HBox. This will create a nice space. And then for the V boxes, do the same thing. And we can leave it at 10 for each. So 10 for this one. 10 for this one. Need this as just by itself. You can actually make this bigger too, but since this isn't part of our special button, it needs its own minimum size. There we go. Okay, so we go back here, and now when we click on it, there we go. So now we have our number pad. And then when you click on a node that's at the bottom here, you see another problem. Now that we made it bigger, it's going to actually clip outside of what the user is able to click on. And we're going to be fixing this in two ways. The first way we're going to be doing is moving the number pad up whenever we're in these groups. And another way is we're going to be giving the user the ability to drag the entire board later on. But for now, let's do this simple fix. So we're going to go to the number pad. And we're going to say that its position is actually going to be if get parent. If the get parent group, so remember the parent of the number pad is going to be a cell. So we can access its group variable. If the group of the parent is in the bottom three, so 7, 8, or 9, we actually want to do that the position of the node is going to equal the get parent position plus, let's say, vector 2. We're not changing the x here, so the x value can stay the same, so we can do 0. And then we want the y value to go up. So if you remember anything about coding, is that y values, positive values go down for y. In this case, negative values go up. So let's do maybe 150. And then we say else. I forgot to do an in here. So then we're going to say else, then the position is this. So if that works, we should be able to go here. And what do we do here? And of course, I made a spelling error. So let's try that again. We go here, we go here. Okay, so now our number pad stays inside the grid. So our users will have a better time clicking on it. Okay, so now we have that. Let's work on actually submitting the number we click on. Because if you remember, we currently have no code for submitting what we click on. So we're gonna go over here to our special button. And we're gonna say that whenever the special button is pressed, we're gonna need to go here actually. Let's give the subcontainer a group name. Let's go ahead and spell grid. That's our class name. So make it a group name too. And we're gonna go back here and say, I want you to get the grid. It'll be a type grid, of course. tree. That get first node and group. Cell grid. Since we only have one cell grid, this will work. And the only time we will ever be using the button is if it's inside a grid. So normally, whenever you do this, you want to make sure that you do a check to make sure it's not null. So if grid does not equal null, and then you do the rest of the code. But since the button will only ever get called while there's a valid grid, there's no need to do that check right now. So we're gonna say get the grid. And another thing we're gonna need actually is whenever a number button is ready, so on ready, we're gonna have the number pad. There's gonna be a type number pad equal to. So the reason we're doing this is because the child, the buttons, are not a child of the number pad itself. It's a child of the HBox container, which is a child of the VBox container. So if we do get parent every single time, we have to do 3 get parents to get a number button, the number pad. So it's easier just to get it done here. There are other ways of doing this, of course. I just like doing this way. Get parent. That get parent. That get parent. Or the easier way is to get the tree and just do what we did for the grid. Since the number pad has its own group. And we're gonna say, so we're gonna submit that to the grid. We're gonna call the input answer. It takes in a cell and it takes in a number. So the cell we're submitting to is the number pad's parent, because the number pad's a child of the cell. So the number pad parent, so number pad that get parent. And the number is going to be, since there's a button, is going to be the integer version of whatever the text of this button is. So if you remember, buttons have a text value. We're going to be getting that, but since this is text, it's a string, we're going to make sure we turn it into an integer before we submit it. So get the number pad, parent, and then turn the whatever the value of the text is into an integer and submit it. And then we want to do number pad, get parent, dot remove number pad, and then we say number pad dot q. Keep doing that. Number pad dot q. So we've done pretty much everything now, if that worked correctly. So now we go here. Let's see if we can solve one real quick. What's a simple one? Right here. So let's see. We have a 1, we have a 2, we have a 3, we have a 4, we have a 5, we don't have a 6, and we don't have a 9. This line already has a 9, so then this line must be a 6. And we go here, and this says non-existent function remover. Whoops. Remove child. Make sure you got your spelling right, people. So let's try that one more time. Okay. So let's see. A simple one will be this one. Okay. So we're missing one number here. 1, 2, 3. Looks like it's a 4. So 4 and boom. Okay. So we got the number correctly, and we changed, and we were able to input our number correctly. Now, one thing I want to change before we finish here is create a different color. Let's call this. Let's make it. Let's go for like a light blue. So let's say light blue. Your color. Type color. Let's see what's nice. right, more to the green side. Okay, so 12, 83, 82. Let's go with 12, 83, 82. And we're gonna say that if the button if the button is no longer guessable, so if it's guessable, we do that. But if the button is now guessed correctly, we're going to change the button color to light blue. So you want to make sure you get your order correctly here too. And you want to make sure you have here if guessable is first, and then if guessed correctly. And it's button color. So now when we guess a number correctly, we're gonna be able to do this. So see, 1, 2, 3, missing a 4, no 4's here, missing a 5 and a 9. This already has a 9, so this must be a 5. So there we go. So now when we input an answer, we get a more clear picture of that. Keep track of what numbers we inputted ourselves and what numbers were already there. This also makes it, once you enter a number correctly, you can't click on it, of course, because it's no longer guessable. These numbers can't be clicked on either. Only the guessable numbers can be clicked on. Okay. That pretty much takes care of that. The last thing we need to do is that when we input an answer, if we do hit our mistakes, we want to create a game over scene. So we're going to go here, go to panel container. We're going to make this one a full screen panel container. Call it game over. Give it a label. Give it a button. The label's going to say simple button that says try again. Let's give it a V box so that it's actually in order. Okay. Set this to the center. Okay. So now we save it as part of the UI. And now we're gonna go over here to our cell container. And whenever we make a mistake, we're gonna go ahead and say that we want to get the tree. And change theme to file, game over. So if the mistakes reach 0, we're going to show the game over screen. In the game over screen, we want to give it a script. And we're going to say that if the retry button is pressed, then we get the tree and we change the file into our cell container scene, which will start the game all over again. So let's make sure that works. Go over here, click on some bad information. We should get 5 tries and boom. Okay, there we go. So there we go. We have a working Sudoku board. It generates a valid Sudoku board every single time. We're able to input answers. Oh, we forgot to put in the button, of course. If you input the correct answer, we get a color change here to show that it's the right answer. If not, you get 5 tries to fail. And then if you press try again, you come back to a different board. Okay. That's about everything we're going to do for this part of the video. In the next part, we're going to be covering adding in a canvas layer to show our mistakes, to make them visible. We're going to be adding in a hint button. We're going to be increasing the visibility of this board. We're going to be making it more mobile friendly by making it draggable, making it zoom in and zoom out, and that's going to be some fun stuff. If you enjoyed this video, please let me know down below. If there's anything you think I did wrong or could change up in the program, let me know as well. And we'll catch you at part 2. Thanks for watching. Have a good day.